Hello everyone, my name is Wahid Lutfi. Welcome to my web university free educational videos. That's my YouTube channel where I bring you a lot of computer science related topics, Unix, Linux, Windows operating system, Python programming, shell programming, bash scripting, C, C++, all of that. And you can see that there are a lot of videos. The one that you might be watching here is one of the video that is here for Linux from zero to hero. It's about 4 hours video that's gonna teach you a lot of stuff on Red Hat Enterprise Linux 9. And this one is advanced Linux operating system, Linux Ubuntu in particular. I'm covering a lot of advanced levels. There's about 8 of these videos for advanced levels. You should be looking at them, and then some of them are posted on my webuniversity.com website, as well as I actually have this book that I have called The Direct Path to Linux Ubuntu, which I'm going to cover some part of it tonight. And then on this book, for example, on chapter 4, I have covered all of those advanced levels. And here, the advanced commands for each of these rows, you will have a particular video that are video 1 through 8. And all these 8 videos are for that list of commands as we cover like gcore or gdb or lsof, any of those commands. Basically, I have the command shown here with the documentation, and you can practice it online as well as you can watch the video and learn it from there. But tonight's topic, I'm going to be covering bash. So let me go to the presentation. The PowerPoint presentation, I'm gonna go through a slideshow. Tonight we're gonna cover bash, which stands for Born Again Shell. SH is Born Shell. So bash was, Born Shell came out in about 1969, 1970s by Ken Thompson and Dennis Ritchie. So at the time that when GNU and the AT&T version that was released, Born Shell was already doing a lot of utilities and a lot of GNU awk stuff, and in addition, a lot of the shell scripting was all written in SH, which is Born Shell. But then the predecessor of that one, actually a superset of it, was introduced called Corn Shell, KSH. And then we had the C Shell, which was C-like syntax, CSH. And then the CSH was through C Shell, that was enhanced version of C Shell. And then Bash, 10 years later, in 1989, I believe, was introduced on, which is called Bash Born Again Shell. And then the latest version, and that is a superset of all of them, were covering C Shell, through C Shell, Corn Shell, and Bash all as a shell, is called ZSH. That's why the letter Z is like the predecessor or the newer version of all of them, the superset of all of them. But Born Again Shell, Bash, is almost like a Python or JavaScript version on the Linux and Unix environment. 90% of the developers are familiar with it. All the people that they use Linux and Linux, they most likely use Bash. Some people use ZSH, some people use Corn Shell, some people use C Shell, depending on their taste. Corn Shell, Born Shell. The entire operating system is backward compatible with SH, but Bash is kind of like the choice for people that they are developer mostly. The majority of them, like I mentioned, as if you're a Python programmer or JavaScript on the internet, the majority of people, although everybody uses C, C++, Swift, Go language, everything, but the Python and JavaScript and JNode or Node.js and all of those ones are kind of used more compared to everything else. Bash is like that also. So Without further ado, I want to just go to Bash and cover all of it. But the topic of this video is Bash tutorial. So I'm going to cover this time Bash tutorial on Linux Ubuntu. As you can see, it's a crash course on Linux Ubuntu. So every command that I'm doing for package manager or file manager or Ubuntu, not Red Hat or not CentOS, not other ones, but there are going to be other videos like I showed you earlier for from zero to hero. That is also commands that are all covered, beginners, intermediate, and advanced level for Red Hat. So this one is on Linux Ubuntu, but I'm covering Bash, which is Bash born again shell. And then as you can see here, if you type in host name, it shows you the name of the host. In this case, my web university, which is mywebuniversity.com is my website, and my web university free education was video. So I named the host name my web university. ID-UN, U meaning user, and give me a name. So this shows that I'm logged on as Wahid. Who am I also shows you Wahid. And then if you just do who space M space I, that also give you the user ID that for the remote login, display session and IP address, all of that also displays there. I'll show you some of those ones as well. Print working directory, PWD. I'm going to cover a lot of these commands here. So as an example for this tutorial, on the thumbnail, I'm going to show you what I'm covering on this video. This is just the surface of it. It touches there. I cover a lot more on this one. That was just on one screen. So the calendar command, and 9070, this is the epoch calendar. That's why I like this date or month. The epoch calendar, January 1st of 9070, was the birth of Unix operating system, which was introduced at Bell Laboratory by, God bless him, Dennis Ritchie, and thank God Ken Thompson is still alive. He's the co-author of Go language, also in addition to doing the AT&T version with Dennis Ritchie back in 1970 at Bell Laboratory. The AT&T version, they built that one. So I'm going to just go to the next slide. On this one also, I'm typing the hostname command, the hostname CTL command, which is give you the details of it is a virtual machine. So that way, if you want to know if a Unix machine is a server or a Linux machine is a server or not, the hostname CTL is your friend. It shows you. There's a lot of other commands that we can cover also. It will show you those details. DMID code is one of them. Hostname CTL, and then grep -i, $sign, a subset of a hostname, that command. It will just run the same command here. So it shows you that cat -n in line number, etc hostname, it shows one line number. I'll cover all that thing. Let me just go to the next slide. So this is one of the book that I have called The Direct Path to Linux Ubuntu. For Linux Ubuntu, I have written the entire book, which is chapter 1 is Introduction to the Linux and Unix operating system, along with all the AT&T Bell Laboratory kind of information there, as well as chapter 2 is the basic commands that I'm covering. So this one has, chapter 2 has about 33 commands. I'm going to go actually to the website, show you dynamically that one, because it's all online available. And so instead of showing you this presentation, let me just go to the online, and I'll show you the entire chapter 2, chapter 3 and 4, 5 and 6, all of that. And so let me just come back to the website here. So if I go to the website here, which I'm already in on mywebuniversity.com, as you can see, let me go to the main page. So the main page is basically bring you this. I have some of the videos that are, I'll put them in there, that is pointer to the YouTube channel, but you can click next here, and then it will just go to the table of contents. And this book that I wrote for teaching you online all the commands that we have covered for basic, intermediate, advanced, and also shell scripting, as well as Linux manual pages, which is chapter 7. And chapter 6 is Linux web server, which is Apache. And chapter 8 is the Linux Ubuntu manual page in a PDF format. And we are going to do that one. And then the C and C++ header files, also in PDF files. Some of these ones, just like chapter 8, is about 6,600 technical documentation that are manual pages. I wrote a Python script to just basically give you all these manual pages online available. So you don't have to buy books and you don't have to do anything. The entire Linux manual pages, I converted from the text to a PDF version. So whichever one you click on it, you will get this PDF version. Because it's a Linux Ubuntu, I just have that topic there. And if you just make the screen a little bit smaller, it is much nicer looking, and you can read the whole thing, depending on how big it is. Some of them are 400 pages, but it's still it's available online for you. That's why what I meant by not just going it. And this one is section 1 through section 9. So section 1 is there, section 2 is there in a very nice table, all of them, and section 3, 4, 5, 6, 7, 8, all of them are here. Whichever one you click, let's say you click on this, whatever that command was, VIPW, and then it just shows you that command there with all the details. So about 600. So if you're looking for like example, let's say Control F, you can search for a command, say bash itself. So if you're looking for bash, you can see here there's 2 out of 6. So if you're looking for bash, let me make the screen a little bit bigger. Yeah, this is the main bash born again shell. So you could click on it and then you just read bash syntax and all the for statement, if statement, while statement, all the syntax with all the variables, set in, print env, all of those ones are here. So let me go to the bottom of it, see how many pages it is. 269 pages. That's pretty long. So if you are reading it like you see expression 8 and expression 2 and all that, not expression through F, there's all details are there. If statement, for statement, while statement, everything is there. So that's the documentation on my Web University manual pages. And in addition, if you go to the same one under table of contents, let me just jump into another section here. You have also the Linux manual pages in command line, I'm sorry, in HTML format here. So you are just getting this screen here. You read the command, for example, let's say you're looking for bash, you just type in bash and you'll just get bash here, the information, the manual page, and just read it. So depending on your choice, whether you like the PDF version or HTML version, you could get it. And if you're interested, for example, let's say, how do I do a calendar command? And then just whatever command that you're looking for, you get the output of it. It is all dynamic. So let's say uname, you get the command here. In addition, if you're looking for like all this syntax here, you memorize it, you learn it, and you say, well, Wahid, this is good that you provided, but can I practice it online? Yes, you can. And I made the entire cloud environment available for you. So on my book, I made it, depending on chapter 2 or 3 or 4, I made it for you so you can just come online and just practice it at my website, at my web server, which is a Linux server, and practice it online. So if you're looking for a command, for example, let's do a df command. If you click on the df, this is going to give you, let me just make it a little bit bigger. The format of the syntax of it, it says that what is DF, and it tells you the DF, what is command part of it. It displays the file system and disk space usage. And then here are some examples. So you click on the df-h, it will run this command on my Linux server, and it will produce the output for you. So this is the df-h command that you click, and here's the output for you. And then you just go there and read it. If you just make the size a little bit smaller, and then it might look better in that way. So you just look at it this way. And then let's say you learn the df command, and you just say, what is df-h, human readable, but f file extension. So the file system is extended for file system Linux. It just shows you all the Linux extended for file system. And then in addition, like for example, you want to get the manual pages for the df command, you click here, and then it will just take you to that page that I just showed you, and it will just open up the df command here. So you can read it on and practice it. And then if you just needed to size it, this one, a little bit smaller, and then now you can just, it's still a little bit too big for this screen, yeah. Right here, now you have the status bar here. You can just scroll bar, not status bar. A scroll bar, you can go up and down and read that one. And if you say, well, I read that one, what about the uname that you were telling me? Uname command, here the manual pages. So the uname command, I covered it on another section. So let me just go back here and say, go to chapter 2, for example. The chapter 2, if uname is right here, yeah, uname is right here on chapter 2. You click on it. It's similarly, these are banners from the Google, the advertisement from Google, but the command actually here. So let me just make it bigger here. What is uname? It shows you the uname command here. And now if you just type in uname by itself, it runs the command and it just give you the Linux operating system. If you type in uname-a for all, it will run the uname-a for all and gives you all the parameters of the output of Linux, Ubuntu, the name, the machine type, the revision, the build, and everything. But if you want just the system name, which is Linux, you -s, it will give you uname-s Linux. And if you just type in uname-n and the node name, which is whatever the node name is, www.mywebuniversity.com, that's my web server, that will just give you that. uname-r will give you the revision. And then you can see here, that is a revision, the build of the kernel. So it is all dynamic, and then you can just go and if you just say, well, this is good, what if I see the man pages? Here, the man pages again, for that section, it's showing you here. Okay, so let's just look at, when I say it's all dynamic, you can just also type in, for example, on calendar, right? So as we can see the date for here, if I just say calendar, just run this month calendar, which is June, then it's going to show June 23rd. And then if I just come here, and instead of calendar, for example, I come in, since I know the syntax of this command, I could just type in command is equal date, then it's going to just run the date command for me, and it just shows that it's Friday, June 9, and it's Eastern time. At this time is 1:43. Pacific Standard Time is 10:43, which is our Southern California time. So here you can also do some of those commands, like for example, uname +-a, that will also run the command, show you the uname-a. So where you either click on the command to learn it or practice it there, or just, you know, you have a choice. It's all up to you how you want to learn it. For each of the chapters, basically, like chapter 3, for example, and let me show you a couple of things here. If the command is that you cannot practice it online, then I'm showing you how to, like for example, change group, change mode, change ownership. These one require privilege. And I don't want to just a hacker to just change ownership of a file and then later on hack the system. So on that case, I just present you these details of the documentation with how to do it. And I say, what is change group? And I show you example and define it. And then I show you all the examples here with one by one, showing you how to do it by reading it, the documentation. In addition, if you do the change mode, for example, let me just make this size a little bit bigger. So for change mode, if you look at it, what is change mode? I'm explaining here, but the change mode has a lot of definition with octet number, as well as UMask and all the details. So right here, I have this table that I explain the read, write, execute, and what is the octet number equivalent for them, and what those permission means. So you can understand that when all bits are dashes, means octet is 0. And then this is dash dash x, meaning to the power of 0 is 1. And then this is to the power of 1 is 2. So and that is a write information. And this is 2 plus 1 is 3. And then the other one is like, for example, 7, all bit is set to the power of 1, to the power of 2, to the power of 3. I'm sorry, to the power of 0, to the power of 1, to the power of 2. So 4 plus 3 plus 1 is 7. And then here I explain it to you, all the details here, how the binaries converted to octet number. So you're welcome to read those ones and practice it. But tonight I'll cover a lot of that one on the Linux machine itself. So one more chapter I'm going to show you here. For example, in chapter 4, obviously these videos are going to help you a lot. So you can watch the videos as well for each of those chapters. On chapter 4, you can see there's a lot of commands here that I'm covering. So like sometimes like if it is system administrator command, like user add, user del, user mod, or group add, group del, group mod, I'm just explaining it here because I don't want somebody to just add user account on the server side. But I'm generous enough to just provide you the entire cloud for you, so you can practice it as you want, and by just coming onto these kind of tables and practice it online here. And if it is not a kind of a permission issue, then you just have to learn it through the documentation that I provide you here. On top of it, I like you to understand that some of these commands are just, when you're coming to my book, you're not going to need any Linux or Unix or a virtual machine or Docker or Amazon Web Services to be up and running. You just need to have an internet access and visit my website. The rest of them are all here. The rest of them are all available for you. So all you need is internet access and desire to learn, and you will learn everything here. And I can guarantee you that by finishing this book, you will be a senior person at the Unix and Linux environment, mentoring other peoples, because there's at least 66,000 technical documentation altogether, maybe at least 6,000 PDF files, 6,600 PDF files, and thousands of commands and videos and everything that are online for hours of videos. Some of them are 4 hours, some of them 2 hours. I explain it. And each one of them, I explain it, whether it's Solaris platform, Unix, Linux, all of that one, Mac, there's a video for it, programming languages. So you're going to learn a lot of stuff there, okay? And then whether it's beginners levels, intermediates, or advanced levels, or shell scripting. So like here, this one, I also have some shell scripting that you can practice those ones as well. But let's get back to the Linux Ubuntu and show you Bash. Because all of this thing that I did was on Bash or Python scripting to just make it happen. on a web server. So as you can see here, I'm logged on a Linux Ubuntu VM virtual machine. So I'm going to log in back here because the screen kind of is asking me to log in. So as you see, this is a graphical user interface on it. It has Firefox, it has Thunderbird, it has a file manager, it has Redinbox, and it has LibreOffice, like similar to Microsoft Office, which is free. That you have Impress and then calculators and Excel calculators. And then Ubuntu updates. And so every time, if you want to do the graphic updates, you can use Ubuntu software update and this one. And then if you are doing it from command line, app update or app upgrade will be your friend. And then this is help for it. This is the terminal shell. You can get the terminal shell from here or right click here and open up a terminal here. You can do that one as well. So let me just close this one. I will show you the other ones. This is a trash, and this is kind of like show application. All the applications that are already installed. You can install additional application by software Ubuntu updates, and then or just apt install command from the command lines from Bash. But when you open a terminal, this one is going to be the same as you click here or the right click there. So that's all in there. So if I just click on the existing terminals that I have open, you can see every time you just open a terminal, by default, whatever your shell is going to just open up that shell, and it's going to show what is the user ID of the person that is logged on at the host name, and then colon, tilde, this is the home directory of myself, and this dollar sign is the prompt. So how do I know that information? There's something on Linux, it's called prompt shell 1. It's an environment variable that they store it, and there's some kind of echo coloring. This /u is this equivalent to that Wahid there. @/h mean at host. So this at host is, and this one for Debian is called mywebuniversity.com. And then the Debian change root, all that information or variables that are there. So the coloring scheme, when you do a 0, 1 is boldface. And then all these coloring scheme, just when you do want to just put it in that color that I did, like 33 is putting a green and 36 is a blue and so on. So you could just get that coloring scheme, whatever the number it is. And then after that one, this /w, right here, /w is the home directory. So if I cd to another directory called, let's say, desktop, then now my /w changed to the desktop here. So if I cd cd 2 dots, and then it is going back to where it was. So let's just clear the screen here. I'm going to do echo $PS1 here. Again, as you notice that my prompt shell 1 is set to this. If I want to change my prompt shell 1 to something else, there's an export command on the bash, allow you to change it. So the variable is called PS1. The $PS1 is echoing the value of it, but PS1 is the variable itself. So PS1, if I want to just change it to only $, and then a space here, now you see that my prompt shell 1 changed. So if I just say echo $PS1, you will see that whatever I assign it here, it is done on that one. So if I just want to back the file, there's a file here on the home directory of the user. It's called .bash or C, which is stand for bash, which is my shell, or C run control. So the .bash or C and ls-l etc bash or C is etc. Let me just say etc profile. Profile is one of them, and then etc. Let me just see what is under bash. Yeah, etc bash dot bash or c. Yeah, etc profile and dot bash or c. So if you look at the ls minus la dot bash or c, and then ls minus l dot bash or c, etc profile is on those two files or setting your environment basically. If it is system file, it's on etc profile. If it is per user, it is depend on what shell they're using this. So if I'm using bash, which is echo $ shell, is gonna say /bin bash. I could say also which $ shell, it will say bin bash. I could also do a PS here, and you can see that my current shell is bash. If I say echo $, it's gonna prompt this process ID of the bash. So if I change another bash, if I just open one more shell, it already read this .bash or C from it and changed my prompt shell 1 back to original one. Because on the .bash or C, if I do a grep minus I, meaning ignore the case. So I look for the PS1 here and say .bash or C, you can see that these are the variable, and that variable setting is automatically set there. So clearing the screen here, let's say I'm here and I want to just say export PS1 here is equal, let's say Wahid at algorithm. So if I just change that one to that, and now I change my prompt to that. If I just say change it back to $ this, and then now I made it that. So when you do echo $ PS1 here, prompt shell 1, it is done that way. If I do this and then I say echo prompt shell 1, now it says Wahid at this. But remember that as soon as I use a bash here, automatically run my bash or C, and it changed my prompt here. So notice that I opened 3 bash here. So this one is the last one. If I do echo $, it's gonna point to this last one right now. So $, is pointing that. If I exit out of this one, now I'm back on that one. So if I just say echo $, and as you can see, the number is different because now I'm pointing to the last bash. So if I just exit out of that one, now I say echo $, my last shell, echo $PS1, is also pointing to the same one. So PS minus PS itself is going to show the last one. If I exit of this last one, it's going to close this one as if I click here on X, close the tab, because this is the last bash. But if I want to go to another shell, rather than closing it, watch, if I do this one, $, now if I say C shell, if I don't have C shell, it's going to say, you want to install C shell, you don't have it. So by default, it did not come with it. And then I could do sudo apt install C shell. And then provide my password here. Because when you do sudo, you're telling the system which user do, run it as root. And then now say which C shell it is available there. So clearing the screen, and then type in which C shell it is there. PS equal $. Now if I want to go C shell, notice my prompt shell 1 I changed to the percentage because I become a C shell user. So echo $shell is pointing $shell, I missed the L, echo $shell it is just showing I'm still at bash. But if I just say PS and then echo $sign is going to show the 162.818, which is the C shell. So from here, if I just have a true C shell, I could just say, well, get to the true C shell, but the true C shell is not there. Which true C shell? So I could say sudo apt install true C shell. So when you do a true C shell, because the superset of C shell, automatically C shell comes with it. And so now I have true C shell, clear this screen PS. Notice that if I say which C shell and then echo $sign, it is going to still show the C shell. But if I say true C shell, now I change my shell. Now the prompt of this one is changed to my web university greater sign. So if I say echo $sign PS1, notice that one is that prompt with exactly what it should be. So at this time, I'm going to exit out of this one and then do echo $sign PS1. And then that's $sign also. Clear screen. I'm going to say exit out of this. Yes. Now I'm back on bash. So if I want to get to corn shell, for example, I could say which corn shell, and corn shell is not there. So I could say sudo apt install corn shell. But because I have bash, I don't need any of those ones. I can always remove it. I just want to show you other ways of commands that you could do apt install and then which corn shell. So now if I say corn shell, now my shell is changed to corn shell. And then that's the $sign. If I just say, let's say, I say PS, I'm sorry, echo $sign, it will show the process ID of the corn shell, which is the last one that is 71 right here. And right here is 71, right? So in order to do that one, let's say just exit out of this one and then clear the screen PS. Now I want to say which ZSH. So if ZSH is not installed, I could say, instead of the sudo, I want to become root. So I could show you more commands how to become root. So in order to become root, you can also do, whether you do switch user do, or you could do su switch user dash root. That is not super user, it's switch user. And sudo is not a switch user, super user do, it is switch user do. Because when you do sudo, you could put dash root or dash wahid or dash another user. That's why it stands for switch user. Okay. So at this time, if I just want to become root, I have to have the root password. And then notice that my prompt changed to root at mywebuniversity.com. As I told you that each user, my current working directory is this. There's a file called the -rc here too. So for the root, if I just say grep ps1 from .bashrc, it tells it that when it's root, you have to change the prompt, and that's how the prompt is changed. Notice instead of the $sign, this one is indicating the pound, which means I'm root. So I could say echo $sign ps1, and that's still showing the U. Since the user ID, let me just clear screen, do this. Notice the /u, and this case is root. So you root, if I say ID-UN, it shows that root. And then host name as still, host name is still mywebuniversity.com. Host name is still mywebuniversity.com. And then the next directory that I'm using is still the home directory of root, which is this. So I can say get and password root. This will also say that the default home directory of root is this. And then if I say pwd my current working directory is root. PWD stands for print working directory. And so I'm going through some of the commands, and some of them I explain it in more details because some of them are very basic, some of them are a little bit intermediate, some of them are advanced. I'll just go cover as much as possible, so you can just within 1 hour or 2 hours, you could get a very good understanding of Bash and the environment and everything. So here, what I'm going to show you, the print working directory, for example, some of the commands that you can do. Whenever you're on a command, if you type in ls, you will see the list of files that are there. If you say ls minus l, it shows the files with certain permissions that are belong to that one. So ls minus l, as you can see here, there's a directory called snap, and this D meaning it's a directory. When the first character shows it's a directory, and then this permission says that the owner root, which is root, has read, write, execute. It's a 7. And then the rest of the group has no permission, because root can do anything. Even if I change this one to all zeros and that dashes, that root, as long as the owner is root, root can do everything on that one. So whenever you're requesting on a device some work to do, the root or a supervisory mode kicks in to the kernel, makes a request on behalf of the user, and the user root has higher privilege. Sometimes when you want to install stuff, you just use sudo or root access, and then do upgrade of the system, update of the system, running any commands that are higher privilege with root access. Other than that, if the file is having permission like this shell script, VirtualBox post install.sh, it has read, execute. It does not have write permission. So even root does not have the write permission, but root does not matter. If your owner as root, you don't have to have, these could all be zeros, and root could still write to it, remove to it, update this file, anything. Root can do it. But for other people, when you just don't give it permission to the group cannot write to it. In this case, the group is root, it still could write to it. But other people right here, meaning that they're not root a user and not group root. So that is considered other developers or anybody else. So that is some permissions here. And then the other thing that I want to show you here, if I just exit out of root, now I'm back here. Let's just check on the ID. Notice that the ID that we did this one, I want to just become root back again, and then switch user do. And then since I already logged on, the profile knows that I already logged on with the password. So it reads it from the cache, and then it just says, okay, I put you back into the pound root. If I type in ID here, it just shows me that user ID 0, the user is root, and then the group ID 0, and the group is also root. And then if I say groups, then it tells me that my group ID-UN is going to show me user and name. ID-U, it just shows you 0 because it's the root user ID is 0. ID-G is also showing you group 0, and then ID-GN shows you root also. So ID-GN will show you this. Get end password root also shows you the root is user ID. There's an entry on the password file, on the shadow file, and then user ID is 0, group ID is 0. The name is root, and the real name, and then the home directory /root, and then the bash is /bin bash. So if I say echo $shell, $shell, all uppercase, it says bin bash. And the $home is going to say /root. The same thing if I exit out of here. Now I say ID, notice the user ID of Wahid is 1000. So ID dash group name is also 1000. ID-username is also 1000, but ID-GN for group name is Wahid. ID-username is also Wahid. So if I say clear screen, get end password Wahid, you can see that is home Wahid and Ben Bash. So echo $ home is going to show home Wahid, and echo $ bash $shell is going to show Ben Bash. And at the same time, I could just also say env to get the environment, and a lot of that information is there. So clearing the screen, env, and then grep -i, let's say home, that you can see that print working directory. Echo $ print working directory is the same as pwd. Echo $ home is the same as echo $ shell, $home, which I did already there. So the other thing that you could do is, for example, on the environment variable, there's a lot of stuff. So env environment variable more. You can see the shell is there, the session, and then the print working directory. All the details are there. Environment command is your friend to just get it. Set is another command similar to environment. It will give you all the global variable as well as local variable. Set is the command that you could run and say, show me all those commands one page at a time with set 5 more. And so on Linux and Unix and other ones, there's a kind of phenomena that is called piping. When Dennis Ritchie and Ken Thompson was not having enough memory, they had to just basically come up with this brilliant ideas of piping. So the list of the commands here you type in, it might be a lot, and sometimes you could have pages and pages of the lines. For example, if I do a list -lr, meaning that list -l and long listing, uppercase R recursively, this is the root partition. So if I do that one and do a 5 more, then it's going to just do a lot of them. And look at how big it is. This is thousands of files. So rather than scanning all of them, I'm going to just say, let's say, head -50 of them. So show me the top 50. And if you want to see like something like head -5 of them, you just get this one. So this idea of piping, it helps you that just whatever command you run, and instead of running it so much, and then you are getting the output of this. So this /boot EFI, it says cannot open the directory because that directory is owned by root. In order to see that file, you have to do sudo in front of it, and then you see that when you don't get the error message. Clear the screen. Last is another command, shows you what are your commands, system login. So if I say head -5, it shows the last 5 times that I rebooted the machine or power off the machine and everything else. So on this Linux VM, as I showed you, you can say host name to find out where you are, what machine you're using. So you know that it is on a host name called My Web University. If I say host name CTL, host name control, and you could also say the static host name is My Web University, and it's a virtual machine class, and then machine ID and all that thing. So in addition to host name CTL, you can say ls CPU, for example, gave me the CPU information. So if you just clear the screen and say ls hardware, and just get all the hardware there. So you can do ls hardware -c, and then disk, for example, class of disk, just to get the disk information. So you can do a lot of these commands here. So there's commands to get system information. So just for the host name, and let me show you some commands that bash provides you, that you can run so many commands to get hostname. One of them is hostname itself, right? The other one is uname -n for node name. Uname -a give you the entire information, but if you need uname -s for the system name, it's Linux. Uname -n for the node name. Uname -o for operating system version. I mean, uname -r for revision. Uname -m for machine type. Uname -p for platform. The x86-64 name. So clear the screen. Uname -help will give you all the details. So if you want to do -s or dash kernel name, it is the same. So all of this information, you could just run one at a time, or -o for operating system and so on. And then that's the information for uname. You can also say there's files in here called os-release, right? So, and when you do a cat etc os-release, cat stands for concatenation. Equivalent to this one is Windows type command or more command. Cat is going to cat a file. So since that file is a symbolic link to another file here that is showing you this detail, if I just want to get the detail of the Linux Ubuntu, I could do cat like this, or clear screen, do cat -n etc os-release. The difference is that -n is going to show you in numbers. Line numbers are there. So as you can see, the line number 3 says version ID is 22.04. And then line number 4, it shows you the long-term support. The code name is Jammy Jellyfish. So you can see a lot of it is right here, Linux long-term support 22.04. And then you can also do a cat -ea etc os-release. And then this one shows you these $, meaning that end of line terminator. So that is very good for sometimes looking at invisible characters on the system. You can also do octal dump to see the contents in octal. But if you want to see octal dump in character format, you could just get it. Notice that every $ symbol is /n for new line character. Every tab is /t for tab, like that there. And then every new line character is /n. And then you can look at those ones here. So the last command that I showed you here, you can do head -5, or you can say, well, let me just see the first time tail -5, and that the system come online. When was that one? You can see this system detail information. And then with disk information, you can do fdisk -l, and this is just giving you permission issue. So I'm going to become root here, sudo -, and then now I'm root, and then I say fdisk-l. It's going to show me all the partitions the way it is there. Notice that the partitions or fdisk is giving me the details here. And then there are dev SDA1, SDA2, and so on. So if I just want to get the information only on fdisk/ldev/SDA1, SDA, it's going to go to all SDAs. But if I want to get it on one, I'll get it on one. If I wanted to get it on two, I could get it on two. There's a lot of other information that you can run. If you do this one by itself and not -SDA, let's say, for example, I could just go and say this is currently repartitioning it. If you want to just say P for print and then print again and then quit from it, you can create it by this fdisk. But you have to know what you're doing here. SDA, for example, I could say P for print or question mark for help, and then M for question for help, and then it will show me all the partition details in there. And then if I just say new for creating a new partition, it will prompt me in those ones, but I don't need to do anything. I'm going to do Control C out of it. Let me just do fdisk dev/SDA. So here, if you just say new, it will just say, do you want to create a new partition? Then by default it's 4. So if I say 4, then it says first sector, I just use that one. And then the last sector. So it is there. Now I say print. Notice that this SDA4, it got created. If I just do a W for write, it's going to just create this size of the disk, and then later on I have to do make a fs on it to create file system on it and use it, but I don't need to. So I'm going to do a Q for quit, and then now if I just do fdisk -l dev/SDA, it is, I did not create the SDA4. So there's a lot of things we could do on these commands there. And then let's see if this one has also clear the screen df-h. Df-h is shows you your current partition the way it is there and what file system they're there. So df-h is your friend for showing what are the file system for each one of them. If you do df-h t, let's say F for extended 4 file system. If you have any extended 4 file system, it will show that one. So extended 3 there. So in order to know that extended 4 file system or anything, there's a file called cat fstat file. You can look at that content of it, and then notice that this is extended 4 file system, the root partition. So you can say df-h file type extended 4, and then you will see the root partition there. You can also do grep -i extended 4 on etc fstab file, and you will see that extended 4 is there highlighted in red. So the way that the grep command is there, there's a command called alias. Alias by default shows all my aliases that are set inside the .bash rc. So grep -i alias on the root.bash rc, you can see all of those alias are there. And if I'm logged on as Wahid, then I have to look at .bash rc of my home directory Wahid. So home/Wahid. But aliases by default are there. And then alias grep command, you can see that it is with -- color. So that way, when you do a grep, for example, $ host name on etc host, this command says run the grep command on $ host on etc host. So now you can see that it is highlighted. The reason I did not put a -i is because I said, well, this command is going to just return exactly the string that it is there. Then it's gonna grep stand for global regular expression print. Grep and piping was introduced back in the 1970s by Dennis Ritchie and Ken Thompson for the same reason of running out of space and memory. So they wanted to just kind of compress the data into a filter it into a shorter kind of data out of thousands of lines into maybe one line and just grep whatever they want. So it stands for global regular expression print. There's also an egrep it stands for extended grep or expression grep or extended grep, which is does the same thing, but except you can do multiple commands on something. So if you're looking, for example, egrep for Wahid or root, and then you look at etc password file, then you will see that wherever it finds those 2 strings, it's going to search for it, and it's going to find Wahid as well as root. And then those match are going to be there. So this OR statement is kind of like either this or that. Both of them just show me the list of it. And then For the grep command, you could see, like you could say grep minus I for, you can use either the $ host name like this on another file called etc host name that will find it, and or you could just say use the backtick. The backtick in Unix and Linux is the same thing as I'm running with this command, which is hostname, that returns the hostname, then it's going to just backtick. So if I just say hostname like that, when you do the backtick hostname, that one is just going to run it, but that one has to be an argument to another command. That's why it says command not found after this one. And if you do a $, then host name, this is okay, but it still shows you command not found. However, if I do this one with grep command and then just look for a file called etc host name, it's going to find it, and it's not going to return any command not found, because what is the command grep command do? It runs that command and then it is going to return it. So whether I use the backtick here or use the sub shell command, it will, both of them works. And then so let's get back to exiting out of this one, going back to the user ID. So here ID-UN, it shows that, and then ID-GN shows Wahid also, and then ID-G shows 1000, ID-U 1000, grep minus I, Wahid, etc. Password is going to show you that. So if I say, give me on etc group file, also there's a group file called Wahid with group ID of 1000. So similarly with becoming sudo root, sudo su dash, and then I say grep minus I password, grep minus I root, etc password, etc shadow, etc group. So on those three files, I can get the information. The shadow files is the entry that you want to protect it. It is password protected. But because this is a VM that's for demonstration, I only do this video and then this VM is shut down, so nobody can access it. When you're not on the network, you're not afraid of anything. Even if a hacker reads the encrypted password, it's not gonna bother me. Because the machine is going to be down by the time that you want to just, this video is released. And so that is the command that you could just look at all of them. And if you're looking for another user like Wahid, you could do the same thing here. And then the group ID get end password, you don't have to type in Wahid or root. You could just say, give me everybody. And then you will see that command there, and it's going to do this. You could say head -5, just show me 5 of them, or tail -5, just show me the last 5. So you can get all this information. And then if you just do this one, say grep -I Wahid. So while you're looking at the password and you're interested for a particular user, then you say, oh yeah, there's an account, get password Wahid, you can do that. And then you can also do this like sometimes, like if instead of this user ID, since it's root, you can say $ ID-UN. So it is going to be the same as if you're saying password root. ID-UN is going to say that. But if you want to say ID-U, let's say Wahid, and it's going to just return Wahid for the user ID Wahid. So there's a lot of ways you can do this. You can also write one line checking for a file, if a file exists or not. So let's say I want to just see if a file exists or not. I just go here, exit out of root first, and then I say, I'm on this directory, let's make a directory called new dir. So now I'm on the new dir, ls minus ld new dir is created, and then a umask is going to show 002 there. So I'm going to say, well, I created the umask 02. If I do ls minus, I did already ls minus ld, I'm going to do stat new dir. So that one, it shows me the permission, it is a directory, and it is, here it shows a file because everything in Unix is a file. But if you look at here, it says that the type of it is a directory because this D indicates it's a directory. And then the information in terms of permission, read, write, all of that information, that is the inode structure, it is explained here. So the inode numbers, all that detail, you can get it, the group ID, user ID, access modification, when and the file can be accessed, modified, and when was the last change, when was created, the birth of it, and everything is there. So ls minus li new dir, it shows you that it is a directory. So there's no file in it. And so ls minus I, it is not there. And I'm gonna say, let's say ls minus ld new dir. I'm gonna say the permission on umask, how that is converted to that. So whenever you create a directory, it is, the way it works is this pound is a command in Linux. So if I just put a command, I put anything here, it is ignored by the operating system. So I say pound, and then I write here, say 0777 minus the umask, which is 0002, and that's going to translate to 0 and then 775, because 7 minus 0 is 7, and then 7 minus 2 is 5. That's how this permission. And that is showing whatever the directory is the directory, and then read, write, execute is the 7. Another read, write, execute is that's next 7 for others, for groups. And then the read dash execute is the 5, because 4 plus 1. And then as I showed you the change mode and stuff, the way it works is says to the power of, so each of these 3 octet numbers, which is the owner, like right here is the owner, and then this, the next 3 is the group, and then the next 3 is the other, that are not owner, not group. Other people considered everyone else. So if you just have all the bits set, this is 4 plus 3 plus 1, octet of 7. This is also 4 plus 3 plus 1 is octet of 7. This one is 4 plus 1 is octet of 5. And that is there. So to the power of 2 is 4. To the power of 1, when it's not set, it is 0. And that is not set. So that bit is off. And then to the power of 0 is 1. And then that bit is on. So 4 plus 1 is 5. And this one is not set, so it is considered 0. That's a umask. So if I just touch a file, touch this, notice that this file has this kind of permission. So for the file, when you create it, it is 0666 minus the umask 0002. So that is equivalent to saying that 0, 6, 6, and then 4. So 6 minus 0 is 6, 6 minus 0 is 6, 6 minus 2 is 4. So that's giving you read, write, dash, read, write, dash, and read, which is 4, dash, dash. So this is 4 plus 2 is 6. This one is off, executable bit is not set. And so if this file is a program that is source code or text file, and normally you don't need executable bit set. But if this is a bash script, then you need to set the executable shell. So let me just show you what I mean. If I say echo, this is a test, and then that is going to show that this is a test. Now let's write this one to a file called t1.sh, just to show you. So ls-l t1.sh, it wrote that, and this is a test inside. And look, t1.sh, it is just there. So if I want to run that one, it does not do anything because that's not a command. That's not, it's just text. So I should have not named it to that case. So in order to just rename this file, and instead of this, I say, do a file on t1.sh. What type of file it is? It shows that it's ASCII file. So I'm going to say, use the move command. The move command, you can change the name, or you can rename it, or you can move the location of it to go. So instead of this, I say move, which is a rename in this case, t1.text. Now I just rename t1.star, meaning that show me any file that starts with t1 with the asterisk. So t1.text is going to show you that. Now if I say cat minus n t1.text, it has one line there. That is there. But if I want to just use the echo command to write that script, I have to do a little bit more than that. So I'm going to say echo, and then say this is a test, and then double greater sign, and then greater sign, and say t1.sh. Now, what does that echo do is it says echo, and then within this code and this double code, whatever is between them, write to that file. So this command is written, and then this single code, t1.sh. So if I say cat t1.sh, now I have the echo that this. And now ls-l t1.sh, notice file t1.star, both of them are text file. But if I just run this t1.sh here, and I say run it like this, that's how you run a script. It says permission denied because of the file t1.sh does not have the executable bit permission. At least for the user ID, it should be set. So you can say change mode u plus x t1.sh. Now ls-ld t1.sh. Notice I made it executable for the owner. Read write executable. So this one changed the color. And now if I say file t1.sh, it shows it's still ASCII text. But once I run it, I say t1.sh, it's going to execute that echo command, whatever command you put it inside here. And in addition, you can also run it with, if I just change the permission back to 4 on t1.sh, clear the screen, t1.sh. Now if I run t1.sh, it says permission denied. So in order for me to run it with bash, I can run it with bash t1.sh. It's still going to do the echo command because I'm telling it to run this bash interpreter on it. I can also do bash minus x t1.sh as if I'm running it in debug mode. The debug mode, it says whatever command I put here is going to run that command, and the output is going to show there. This plus x is really cool in that sense. So you can also do this. Then, so if you say which bash, it is there. I'm going to say use a bash. I could say vim t1.sh, and then on the first line here, I could say shebang, which is pound bang. So user bang and bash, and then run this command here. And now if I just say dot T1.sh, it's going to say permission denied, bash, and then T1.sh is going to run. And then if I just run the script with the bash, I could also do bash -x T1.sh. So if I want to run it with born shell, shell -x bash, T1.sh, that will also do the same thing, because bash is born again shell, but in this case, there's no much syntax of bash, so I can run it with born shell as well. So in order to do one more thing here with this script, I want to just vim T1.sh, and then I'm going to say set -x. This is almost as if I'm just running the command with -x. So I'm going to put a couple of more commands. Let's say calendar command, and I say hostname CTL, and then grep -I, or grep $hostname, $hostname. So that is going to do that. Just these commands are good enough to show you with the set -x option. So I'm going to just, if I run a T1.sh, it's going to say permission denied. So I'm going to say change mode. This time I'm going to use 755 T1.sh. Now I changed the permission to have everybody read, write, execute. The owner read, write, execute, everybody else read, execute. And 7 is read, write, execute, 5 is read and execute. So 4 + 1, 4 + 1. For others, also give it permission. So now if I run it with this T1.sh, notice that because I put a set -x, it runs each command and then it shows you the output here. If I don't want to see the command in debug mode, and I know that I might have typed in something, an error, this is going to just catch all that thing. So notice that I don't have anything in error, vim T1.sh. Let's say I just type in here something extra, a typo. I put a hostname 1, and then that command is going to just fail. So T1.sh, and notice that it says use the grep command. But at this time I say that, okay, what was my command? This hostname 1 command not found, and that option of set -x helped me. So I go vim T1.sh, and I change that one back here. I can comment this one, say don't show this one because now I fixed it. So it is shorter there, T1.sh, and you can see the output of each command showing there. So shell scripting is very easy. If you know if statement, for statement, while statement, which I have made a lot of videos, you should be watching those ones. You can practice. So like, for example, T1.sh here on the Linux, if you just say, if T1.sh exists, then say, and do a PWD. So since that file exists, it is there. If that one is a directory, which is not, then PWD does not run. So if I just say, instead of this one, say ls -l T1.sh, it's not going to run. But if I say that if this file is there, give me the listing. So if I just say, instead of the and symbol, I could say cat -n. You could do this. And then on top of it, you could do another ampersand. So you can do double ampersand, saying that if this command runs, then run this command as well, and as well run that one. So now if I say run the T1.sh, then it's going to run it as well for you. So it's a lot of good stuff here that you can do. If you change this one to an OR statement, that's basically going to just run the first command, which is this. Since that one was this command, let me just make sure. Yeah, this command, like here, the way that's a shortcut. So we call it short circuit. So this command was successful, the and run, and then since it ran this one, then it does not need to check this one. But if I change this one to ampersand and then it's gonna just run the output also. So there's a lot of neat stuff. You can do this. You can also do a PWD and say and run to command. Since both of the command run, echo $question mark give you the status of those commands. So if you go say and do a calendar command, so you can get multiple commands and running at the same time. But this one was one, and that's why it assumed that this is was backgrounded with 1 ampersand. And so you have to do double ampersand to say Boolean operator. Now this is going to do this. So if I just want to run a command that is taking a long time, I can run it with commands, whatever it is, ls-lr, for example. It will run for a long time, and then I can do ampersand to just get it back. So let me just show you one more thing on the command. So if you look at the directory, if it is there, the time is getting late a little bit, but maybe I could have another session and cover more on the bash, because if I cover days and days, there's a lot more to show you the stuff here. So another one you could do like external stuff for the GUI and stuff here. So if I just say which external, if external is not installed, I could do sudo apt install external. So this is going to just prompt me for the password. If I do have the password with sudo access, then it's going to install external, and then clear the screen. And now I say which external is there. So I could say external minus background, let's say dark green, minus foreground white, minus face New York, and minus font size is like 18. And if I just run that command, it just gives me the command here output and clear the screen, date command, calendar command, whatever command you do, if you type in exit, it is there. But if I just would say the dark green, I want it a little bit more darker, so I could put a pound red, green, blue kind of format. So this is red and this is blue. Is, let's say I want it 30, and then for red, for green, I want it 30, and for blue 0. And then you can just get that one. If I want to just ampersand at the end of this one, then it's going to background it. While this command is running, I have the command line back here, there. So I can say uname -a, clear the screen, date command, calendar command, who command, whatever command I type in, I could do that one, or I could exit and then come back here, there. So if I just say, and change this one to, let's say, and then let's make it a little bit lighter blue, not too dark like I have this one. So this one is the color that we did. And if we say xcalc for opening a calculator, you can do this one. Notice for xcalc, when you do this one, it is just showing you this cannot convert this. So in order not to see this one, the system has some nice utility that you could do. I mean, so some nice, bash has a nice way to filter that one, so you don't want to see it. You say, send it to a dev null, but at the same time, if you do that one, it's still gonna just show you that one. And then now you have to do this, 2 greater sign &1. What does that mean is that this one is saying that send it to a device null, redirect it to the device null, so this information, but this 2, it says send the standard error to the same file where standard output is. The $&1 is this dev null in this case. 2 is a standard error. So, and that will just not show, notice here, there's nothing out here. So this command is not into that shell. You can also do this. Let's say xcalc. And then if you just get the output, notice in order to not get it, you just say xcalc. Let me clear the screen here. So this command runs and it gives you output with the errors. And then for order to do it, you just say, you can say xcalc and then greater sign dev null, and then 2 and greater sign &1. That will just give you the calculator, but there's no error, right? And you can move these ones around there. So if you wanted like xi's, you can just run and then get the xi's, and as you move it, you will see the i's moving. So that's xi's. And then if you say xterm, more commands, xterm dash background, you can say, let me have a dark green. Actually, rather than having so many of them, let's just show you shell scripting. So I'm gonna go to shell directory here. Sorry, clear the screen here. When you do ls-ltr, it shows all the files that are there. And if I just say ls-ltr star shells, let's say, do I have a file there? Yes, I do. So ls-ld, it will show the directory that is there. And if I just say, if this is a directory, I could have just say -d shells and then run this command, say ls-ld shells. So if that directory is there, list it for me. You can run that command. If you say now cd to that directory, and then now I'm on this that directory. There's push D and pop D that you can just also do. CD and change directory, dot, and all that thing are very basic. If you haven't or not familiar with it, please watch my other videos because I have covered a lot of them. I want to cover on each one of them a different topic. So here I'm going to the shells, and then I say, show me any file with xterm. And so you can see that I have a my xterm.sh there. So let's just see what is on my xterm.sh. In order to see it, I'm going to open it on my VI improve, my xterm.sh. And you can see that this is, I wrote it a long time ago, and then basically, I don't know when I wrote it, but it is basically just opening a multiple xterm session with different colors and different fonts and all the sizing and everything. So in order to do this one, let's just quit out of here. And then now I say run ls-ld my xterm.sh. You can see that it has the permissions bit set for user ID Wahid. So I can say my xterm, term.sh, and it will run it. And as you can see, it opened these shells. And so if for each of these commands that I run, and it run the command, and then I can do whatever I want to do with it, and then exit it out, and then I'm on the next shell. Similarly, who am I? Clear the screen. Who space am I? And it shows you that my display is there. So if I say cd / go to the root directory, sorry, clear the screen, cd / root directory, that is my current directory is there. I could say who am I? And it shows that I'm logged on. Echo $ display, that is showing you that colon 01, colon 0. And then who am I also shows you that is there. ID -UN will give you that. And then who is going to show you who is logged on currently on the system. So if I say export a $PS1 is equal $, I can change that one to $, clear the screen, export PS1 is equal, not $, PS1 is equal $, this. Now my prompt shell 1 changed. So clearing the screen here, I only have a nice $ prompt. So if I just say who is logged on the system, I can see that one. If I say clear the screen, who am I can see that. Run level, show me the run level there, that is there. Who minus R also show the run level is 5 there. And then system CTL status. So all the systems that are running, you can get from system CTL, start services and everything. Clear screen system CTL status SSHD, for example. Clear screen system CTL status. If SSHD is not running because I'm not installing it, so I could say sudo apt install system, apt install SSHD. So now when I log in SSHD, that means I can later on unable to locate packages SSH. So I'm going to do an SSH, and that is going to install it. System CTL status SSH, and now you can see it is up and running on the port that is listening. Main process ID is there, and PS minus EFA grep minus I SSH, and you can see that is there. So clear screen LSOF minus I colon 22. I'm going to do this one with root. Sudo assume, and then you can see the process of SSH running on port 22. And grep minus I 22 etc services will just also show you that we're running port 22 for SSH there. So clear the screen, system CTL status SSH. You can see that this process is active right now running because I started it, but you can just, if you wanted the system to be running at root level, so let me just exit out of this one and then show you another extern here, and exit out of this one, show you another extern, so all these colors are there. So I'm back in here. I want to show you on the SSHD, grep minus I SSHD. You can see the process SSHD is there, system CTL status SSHD. So it is showing enabled by default. So you can also see, let me just become root first, sudo sudash, and then type in the password, clear screen, PS minus EFA, grep minus ISH, system CTL SSH, status SSHD. If you look at that one, and there's some process here that is showing that is active. So you can say system CTL cat concatenate SSH process D, SSHD. So you can see that all the processes that are running for it, the directive, everything is there. And then you can even do a show, and instead of cat, to just see all the directive there. And then if you want, you can even do an edit. Edit by default, when you do edit, it opens it in Nano, which is give you this Control X. So if you say Control X here, you exit out, and then you say, and instead of a Nano, I want to do export editor is equal VI. So now if I just run the same command here, now it opens it in VI, Visual Interpreter, which is, I could say set list, and it will show list, set no list, set line number. You can see that one. And then if you want to change the schema, the color, you can do that one. And there's a lot of commands here. You could do search, for example, the word comment, and then you could just say search for comment. You can see that it's highlighting it. If you search for a search a D, it will go there, and you could type in N for next. It's a search, and then type in every time you do this. If you want to go backward, uppercase N, it takes you backward. There's a lot of commands here. You can change the word, for example, line 1 through a dollar sign, substitute, let's say SSH D to Wahid. So if I do it globally, now it changed all of them to Wahid. So if I just go back here, say, search for Wahid, and it's going to show all of those ones. But that's not what you should be doing. I'm just showing you you can do set commands and substitute command. I'm not going to write to it. Since I'm not going to write to it, I say quit for sure. It is just the same file. It is now not touched. So I go back to it. I just say SSH, and the file is there's. If I search for Wahid, there's nothing. It says pattern not found. So in order to exit out of Vim, escape, shift, and then colon, and then Q, quit for sure. That's Q bang. If you want to write to it, it's say W. If you want to say line 1 through 10 or whatever, you want to change something to something, you could do that one. And if you want to say, for example, let's say, go to line number 3. It takes you to line number 3. And go to line number 8. That's the line. If you want to do escape YY, copy it and then yank it and paste it, you can do that. Escape DD, DD, DD. And then you could say, let's say this is something I could just do, and then say set MU line number. Now notice that line number 9 through 12 I created. I could do say that's 1, 2, 3, 4. 1, 2, 3, 4. So these 4, I could say escape 4 and DD, all 4 of them will be deleted. And then I could do escape undo, it will be done. I could also do programmatically say line 9, comma, line 12, and then delete it. That would delete all of that. Okay, so there's a lot of VI stuff that you can do, or Vim stuff that you can do here. And the time is already 12 o'clock. I need to sleep, so I'm gonna stop here, and then we will cover more as time allows. And thanks for watching this video. Please make sure that you understand Bash, and if you understand Bash, you have a job somewhere with Linux, Unix, and you can just do everything that is there with the operating system if you know Bash, whether it's graphical interface, command line, or writing scripts. Just knowing Bash is gonna just make you so dynamic with your work. And then obviously, if you know Python on top of it, a lot of the for statement, if statement, while statement, I didn't cover it, but they're very simple. Just as a test, I want to show you a couple of things before I exit out of this one, because I want to make sure that you understand the details of scripting as well. So let's go back to this one. And then if I just say for item and range of 1, comma, dot, dot, 10, and then I say do, and say echo, and the item was so this, and then let's just write a dollar sign item, because it's that, and then we could just do this one and done. So you can see, and the for statement is simple. You could do that for statement, and if you just say with a certain range, you can also change this one to a sequence command. So you can say backtick sequence of 10, and that would just do the same thing here. Or run, and instead of the backtick, you could do the dollar sign sequence here of 10, and then just do that. So that's a for statement. There's also for statement with the similar to the C syntax, depending on what you do for each statement. While statement, so x is equal 1, let's say, and then say while, and then you just do this comparison, say x is less than is the syntax like that, and then you say do this one and say echo the number is dollar sign x, and then here I'm going to do an expression, say x is equal, and then say expression dollar sign x plus 1. So just add it there. I could have also say x is equal plus equal 1. You could do that one also, but let's just do it through this, see what it does. Here, and then so we increment it, and then done, you can see that one. So if you change that one to the other syntax, like x is equal plus 1, that is plus equal 1. So x is already baked, and then we could do that one. The number is 1, and then we have to do here saying that expression x dollar sign x. Let's see if we could do without the use of expression plus 1. X is equal 1. Yeah, so this one would not work, and it will go infinite loop. So you just have to say the command we did it in the first place. X is equal 1, and then that format of expression. And instead of doing this, you just say x is equal, and then expression dollar sign x plus 1. That one will work. Let me just x is equal 1, and then I'm gonna just redo this part with the first syntax, which is yeah, like that the item was no, this one right there. It will just work. And the reason it works is because this x is equal dollar sign x, and then it finds out 1, and then adds 1 to it, and it until it becomes 9. So if you just change this one to another number, like let's say 200, obviously it, the number is going to just go up to 99. And now since I run this one, if I run it again, it's not going to do it. Why? Because the command echo dollar sign x is already 99. So if I, or 100. So if I just change that one back to x, say export x is equal 1, then run this command, here it will do it. So, or say set x is equal 1. And then run this command again, it will, so set, the set is global. So in order to get it there, you just have to do this, and then do this, and it will work. And set x will be echo dollar sign x is not set. So now if I run this command, it will just come up with the x value that was previously set. Echo dollar sign x is still now 100. So if you just, every time you change it, you have to know where and the loop is going there. Now, if I do it with 1000, notice how fast it is. So you could do that kind of programming there. Excuse me. And then the if statement, you can also do if, say, 5 is greater than 10, which is not, then you say, then echo the number 5 is greater than 10, which is not, and then else you say echo the number 10 is greater than 5. So those kind of things are easy. It will just show the number 5 is greater than 10. This greater sign, it did not work. So and instead of doing that one, you have to say dash GT for greater than. If you do a string comparison, that greater sign will show that one. Now notice that the number is greater, 10 is greater. This time it worked it because GT. So this one is for a string comparison. So if I just do this one, that means I have to do a string comparison saying that the string 5, if it is greater than a string 10, because a 5 is going to be compared with 1. So 5 is greater than 1, it's going to give you the wrong information. So that's why when you're not comparing to a string, which is like, for example, character A with BB, then BB, then it will say the character 5. So we have to say AA is there. If you just change that one to AA is greater than BB, and then the otherwise you say BB is greater than A. So that is this command here. So if you do that one, it just shows you that AA is greater than BB. In this case, is the string comparison. And so whatever you're comparing with something, you have to put the right the digits that are or characters that are actually true if you're saying if that is the case. But the one that you actually wanted 5 and 10 is this one. And so if you just compare 5 with 100, and then obviously the wording here has to change to 100. And then this one 100. So that is just saying the 100 is greater than 5, which is true. So the greater sign symbol that are there is there. Man test will just give you all the details here. So all the expression comparison of numbers as well as characters, strings, it's on the test, man test. So you also, on bash, you also have man command. So pwd, you can see clear screen man who, and then the details are somewhere it says user share man, and then all those man 1 through man 9, as well as man question mark. All of these ones are commands. Notice that one with the Ganzip file and the numbers that are there. So if you're looking for like a printf statement, man minus S3 printf statement is going to give you section 3 of it, which is the Linux manual pages. If you're looking at section 1, which is the Linux command, you don't need to type in man minus section 1. You will get it automatically there. Okay. Clear screen man minus K for keywords, and then you can say pwd, and all of that one by keywords are going to stay. Locate pwd is going to show all the commands that are including the manual pages for pwd. Locate itself is going to just show everything about locate. Whereas pwd, which pwd, which ls, which date command, all of these ones, if it is binary like type user ben date, it will tell you base name user ben date, give you the base name, and then dir name is going to give you the directory name user sben. So and that's how you look at those ones. Type of user sben date. I'm looking at data, so let's look at the data again. Type is command sben data. I'm sorry, when the command is not there, I was typing data that those data are not there. So I meant a date. So when you do the base name on, or the dir name of that one, base name is going to show the date command itself. And then if I say file user sben date command, it's going to show that is no such file, user sben date. Okay, so user which date command, file user ben as date. So the date is not an sben, it's the date command. You can see that's executable link format. And then if I say type of user ben date, it is also showing you that user ben date is the command. So if I say type of change directory, that is a shell built in. So man cd, it says nothing appropriate, because that's a built-in shell. So any built-in shell will be inside the bash itself. It will just cd to dot dot, it will just go there. Cd to home wlutfi, cd to home wahid, and then pwd cd dot dot is going to take me to home directory. Cd dot dot takes me to the directory. Okay, and then push d home wahid. Now I'm there, and then I would say pop d is going to just take me back to the directory where I was, and then push d home wahid shells. I'm sorry, let me just cd home wahid minus ld shells. I think I had a directive shells, yeah. So I could say push d shells, and now I'm on the shells directory. If I say pop d, it's going to just take me back to home wahid. So that's what push and pop is happening in there. And then you can also do cd, cd relevant to the directory there, and then just go say, take me to the, let's see, I'm here. I say, take me to the root, but take me back to home, and then wahid directory. So that's how relevant to that directory that is there. And if I just say cd to shells, and then notice dot dots show me the parent directory of that one. So from the current directory where I am, it is there. And then I believe I created a new dir somewhere here, a new dir, yeah. So you can say rm dir, new dir, and it will just delete it. If you just make a copy of a file, let's say the shells, I have a lot of them, ls minus ld shells, and then that's the directory. If I say do a list on all of them, do a word count to find out how many files, 537. So if I say copy minus rp shells, and then shells dot back, I just made a backup of the shells. Now I say def shells with shells dot back. There's only common directories, no differences. So if I say disk usage minus l shells, and then do the same thing with dot back, I'm sorry, dot back, dot back, then you see that one. So rm minus rf shells dot back, it's gone. I just clean it up, and now I just do this one. There's no such directory. So if I just want to tar it up, I could say tar cvf shells dot tar, and then shells. So now I just tar up all of them into a tar file called shells dot tar, and then tar tvf shells dot tar will display the content of it, all of the files that I've done. Disk usage minus l shells dot tar. This file is 5.9. If I want to gun zip it, compress it, shells.tar, it creates the gun zip, gunzip, gzip, gunzip, shells.tar. Now I just created shells.tar.gunzip, and that file shells.tar.gunzip is a gunzip compressed file. If I want to unzip it, shells.tar.gunzip, it just does it, and now I have the file back to shells.tar only. And then if I just want to move the shells to shells.original, so that's my original directory. And then now I don't have a directory called shells. I can say tar extract xbf shells.tar. It just restore back from my tape archive shells there. It's that directory is there. ls minus ld shells, and then disk usage minus sh shells, the same 6.7 megabyte that was there, it is there. So if I say def between shells and shells.original, it says no differences. If I say def minus r recursively, and look at it, it's no differences. $ and question mark shows successful. Okay, so we did a lot of stuff here. I hope you enjoyed it. Please make sure you go to our YouTube channel, like and subscribe our channel. It is for what I have provided. It's at this time it's not enough users, and then maybe we just get more subscription and more likes, so we could just have all these videos. You enjoy it and learn it and use it for your work or in school, and learn from it and make some comments. So if I need to improve for your needs, I will do that. Take care. Bye-bye.